Differential evolution is a method that optimizes a function by iteratively trying to improve a candidate solution with regards to a given measure of quality. This method is used for multidimensional function, but the function doesn't require the optimization problem to be differentiable because it doesn't use the gradient. DA can also be used on optimization problems that are not even continuous, noisy, and etc. Small historical note, different evolution was introduced by Storm and Price in 1990s, and in this picture, you can see two most popular function. This is ugly function and Rosenberg function. And you can see the practice of this method. I wrote this method in Python. Yes, it's not as good as GitHub code or skip optimize, but it allows me to study it deeper. I start with a simple function. It was x squared minus cosinus y plus sinus minus x minus z with some bounds. This function is easily mathematically analyzed and at the same time contains several local minimums. It also uses Sanklin function, which makes it suitable for testing this method. But also you should know that this algorithm is great, but the method different evolution doesn't guarantee an optimal solution is ever found. Next. Yeah, in this picture, you can see main idea and geometrical illustration new points. But I want to say some more. Differential evolution optimizes a function by maintaining a population of candidate solution, combine existing ones, and keeping whichever candidate solution has the best score. In this way, the optimization problem is treated as a black box that merely provides a measure of quality given a candidate solution. In Italy, a set of points and dimensionals space is generated, called a generation. In these points, the objective function which you want to minimize is defined. At each iteration, the algorithm generates a new generation of points by randomly combined other ones. The number of points in each generation is the same, like a constant. The new generation of points is generated as follows. For each point from the old generation, 3 different random points are selected, and we can find new candidate by this formula. You can see in main idea. Okay. A crossover operation, the last step of this algorithm, is performed on the mutation point V, which means that some one of its coordinates are replaced by the crossovering coordinates from original points. Each coordinate is replaced with some probability, which is also another parameters of this method. And then the point obtained after the crossover is called trial point, and the last step, we choose the best variant of this point. Okay, and in last slide, you can see pseudocode. I wrote it by myself, but I said all steps before. and covariance with best fitness and average over 100 generations. Thank you for your attention. The end.
Okay, thank you very much. Very good. Anyone has any questions? Okay, no one has questions. Okay, let's move on. Thank you. Thank you very much.